Okay, YouTube, in this video we're going to define what a function is and kind of talk about how we represent them. And so let's go ahead and start with our definition of what we mean by a function. We say that in math, a function is mapping elements from a set A to a set B. And what it is a relation that assigns each element, and we usually use x here, in set A to exactly one element in set B. And we call this element usually a y. So here's the important bit about what we see right here. In terms of a function, what we're going to see are sets of things starting with A to B here, where we have a mapping or some rule here, some function that maps elements from A to B, but the peculiar thing about this is that every element in A can only go to one element in B. So for instance, I might have a function that looks like this here, and you know, this element goes here, this element goes here, and maybe this element goes to the same one. But the rule here is this: it has to be what we call 1 to 1. So a function is 1 to 1, which means 1x goes to 1y. Essentially, every input we have is going to go to one output. So now this input-output concept, what I want to talk about here is that the inputs, the set of inputs, we say the set A is the domain or set of inputs for the function f, and we say that the set B contains the range or set of outputs for this function here. And so when we define domain and range, we're going to say that all of these inputs that were used here are domain values here, or x values. We can write an x here. And all of these output values are really range values, or what we call y values. Now, one thing I want you to kind of notice here is this: there were some values over here in B that weren't included in the range, but that doesn't mean that, you know, that's anything bad, okay? As long as every input goes to one output. So to help us understand this, we're going to take a look at just a small illustration here that kind of shows a relation between the time of day and temperature. And of course, when you talk about time of day and temperature, recall that one time of the day can only have one temperature that goes with it at a specific location. And so we could say that this relationship between time of day and temperature has to be a function, because look, all of these times of the day on the left are all proceeding to exactly one temperature on the right, even though there were some temperatures that didn't get used. So representing this function, we could represent this using just a couple of sets here in a mapping is what we call this. I'll go ahead and label this here. But we could also use coordinate pairs. And so this function can be listed as a set of coordinate pairs where we want to be really clear on this. We say that the first value here is the x value, and the second value here is the y value. But what we're really saying is that our input value is our x value, and our output value is our y value. And likewise, we could say that this is a domain value is our x value, and a range value for our y value. But in each instance, we can see that, say for instance here, 1 o'clock p.m. Went to 9 degrees Celsius. And so we list this as 1 went to 9, 2 goes to 13 here, and so on and so forth. And we can see that even though there were two different times that had the same temperature, that's not a problem as long as we don't have one time going to more than one output. So the characteristics of a function from set A to B, just to kind of throw these out there, first one is this: each element in A has to be matched with an element in B. So that means that all of these have to be used, and they all have to be matched with something in set B. It can't be a non-mapping situation. For part 2 here, we say that some elements in B may not be matched with an element in A. So what I can basically point out here is this: we had some elements up here like this one, okay, this one here, or this one, or this one, or this one, that did not get used. And so that's an okay thing for all of these elements not to get used, as long as all the elements in set A did get used. Now for these last two, basically number 3 says 2 or more elements in A may be matched with the same element in B. And so an example of this would be like right here. We could see that 2 elements in A actually went to the same element in B, which is not an issue whatsoever. But number 4 here basically states the problem would be that an element in A, or in the domain, cannot be matched with 2 different elements in B. And so we could say for number 4 right here, an example of that for number 4, I suppose, would look something like this, where if we had these elements here, and I filled all these in here, we could say if this one went to there, but it also went to here, that would be certainly an issue right there, because this would be a 1 to 2 situation right here. 1 to 2, because we had an x value go to more than one y value here. And so what we're going to look at here is basically how we represent a function, and also how we can basically determine if something is a function. So the four ways we do represent this are verbally. First of all, it could be just like a sentence, kind of like, hey, you know, my income, I always make 5 times the number of hours as my income, you know, that I work, or something like that. That would be a verbal situation, whereas numerically we could list out, you know, if I make $5 an hour, I can make a table of values to show you that as every hour goes up by 1, I'm making another $5 in the amount that I make there. Graphically speaking, all of those tabular values that give us points here, we could go graph those and plot a graph, but that would also represent our function there. And then last but not least, we could actually use an equation in 2 variables to represent a function here. And so what I want to do basically before we tune out of this video is basically look at example number 1 here, where we're going to determine is this a function or not. So when we look at number 1 here, letter A says the input value x is the number of representatives from a state, and the output value is y is the number of senators from a state. And so what we could see here is that we would have input. This is representatives. Okay, and then our output here is going to be the number of senators. Okay, and so I guess here's the deal. Every state here, if we were to list the number of representatives they have, 1, 2, 3, 4, 5, 6, so on and so forth here, and then represent the number of senators, okay, what we're going to see here is this, 5, 6. As a matter of fact, every single one of these representatives here is going to go to 2 senators per state. So if you have 1 representative, you still have 2 senators. 2 representatives, you still have 2 senators. 3 representatives, you still have 2 senators. So basically, since all of these inputs here are always going to go to 1 output, then we would say this is a 1-to-1 relation. And so therefore, it is a function, Every input would go to 1 output. So for letter A here, we say it is a function because every representative, no matter how many you have 2 senators in your state. So for letter B here, we're taking a look at a table of values as well as a graph here. But looking at the table of values, what we're looking for is, are there any inputs that went to more than 1 output? And right off the bat, we notice that 2 went to 11, but 2 also goes to 10. And because we are restricted from sending a single input to more than 1 output, we can say that this is not a function. Okay. And so for this last one here, in which we have a graph, we could see we want to look for any x values that go to more than 1 y value. Now, one thing I want to suggest is this. If you had an x value that went to more than 1 y value, then you would have 2 points plotted exactly on top of one another. That is to say, if I were to have the point 2,1 and the point 2,3, you could see that both of these points right here are hovering over the same x value. And so one test that we often use is called the vertical line test. But if you ever have a function where a vertical line, if drawn, hits it more than once, then you could say that it's not a function because it's not 1-to-1. In this case, there is nowhere on this that I can draw a vertical line where I would have more than 1 dot above the same x value. And so because this passes the vertical line test, no vertical lines hit it more than once, we can say is a function. Cheers.